Come on in, come on in. Don't be shy. More of the interesting stuff's on this side. Yep, go ahead. Go ahead, take pictures, film with it if you'd like. Come on down. I've got a lot in this group.
Saws.
Hello, everyone. How is everyone doing today? Good. My name's Ryan Bruckman. I'm a lab instructor in the Department of Systems Design Engineering, so I teach systems design and biomedical engineering. And this is one of our undergrad labs. This is the prototyping lab, where we have some electronics, some mechanical, fabrication things. We have electronics on the other side. If you poke your head down the way a bit, you'll see a workshop that looks much like this that is available to students 24 hours a day, 7 days a week for whatever you want to build. So in our department, we build a lot, right? You come in, you learn a lot of math and science, we'll teach you some more, we'll teach you how to design, and we also teach you to actualize your design. So at least 5 of the 8 terms, students will be having a problem, creating a solution, and then building it and evaluating it. To support that, we have a few things. We have about 5 or 6 3D printers of our own. We have a laser cutter of our own. When students come in, you purchase a lab kit, which has a bunch of tools and things that you need to build your project with, and you'll use them throughout the term. Starting in 1A, you start designing things. So the first thing you design something and then you 3D print it. You follow that up soon after with, we give you parts. We take you to the machine shop, teach you how to use all the machines, and then you bring us back the truck.
Oh, the truck.
Right? And after that, we start doing other interesting things with you. So if you see right here, we have some electronics projects. And the one that's working right now, this is a color organ. Let's see if I can play a little song for it. You see these lights shining up there? So this is something that students do with a couple weeks, right? You come in, you learn analog electronics, we have a speaker from the kit, and then you build something with it. There's a couple other ones, these are digital projects, right? So you come in, we teach you how to use some machine tools, mechanical stuff. We follow that up with some electronics. We get into control systems, so this is something. Teach you how to make things behave the way you want. If you can do this, you can design a self-driving car. You can land something on another planet. You can help someone who does not have legs learn to walk. At least we're trying to get there, right? And once we teach you these individual things, we start bringing things
Inverted
together for
parallel.
you. So for example, the lab you're in right now, this is going to be doing robotics starting next week. And they also have previously done a project where we hand you out some parts to do, right? You do parts, you use that to build a useless machine. Anyone ever heard of a useless machine? Yeah, you turn it on, it shuts itself off, right? It's a lot of fun, right? So students come in, you design and 3D print a part, you design and laser cut a part, and then using the tools that you have over here on this bench, you form your own mechanisms. You cut them, you file them, you drill holes in them, you align them. You get it all working together, and then you integrate motors with off-the-shelf electronics and your own custom design and soldered part. Get everything working together, right? So you start linking things together. And we have soldering workshops where you come in and you learn how to do the soldering. We will teach you how to, if you're interested, design and get PCBs built. So you start off kind of taking these individual pieces and you bring them together. If you look at the screen up here, this is from my second year biomedical engineering students, and this was across a few courses. And the idea was you take raw signals and then you bring it into an electronics design that you design yourself, digitize it, design some mechanisms that are powered to solve a problem. So each one of these, students came up with their own idea, solve a problem. pick up using some kind of biosignal, which is usually a muscle activation. What is it that you'd like to do? So some people are pumping water. You'll see people at a fork that is helping people feed themselves. You have someone who wants to steer a car, right? And all that is using multiple modes that you come together. In our programs, you build a lot. 5 out of 8 terms, you're building something, right? So we cover everything from, you have an idea, is it a good idea? Does someone want this solution, right? And you talk to individual people who are actually in that space and help focus your idea into something that someone would want to buy. And then we follow that through with technical design into implementation. And then we repeat and you get better with it as you go. Everyone loves Nerf guns. Does anybody have any questions? Yes.
Is the biosignaling only something that the biomedical engineering people are doing, or does it also apply to systems?
So biomedical engineering students will learn more in depth about it. One of my favorite projects that I had was from a systems design engineering student. They took 2 wires, put it here, put it through some electronics, and did eye tracking in 2 weeks. Right? So engineering degrees are flexible. Well, all engineering degrees are flexible. You have an ability, one of the things you learn is you learn to learn. So you can learn and pick up yourself and pick up other interesting background information for yourself. Anybody else have any other questions? That's for an EpiPen, for someone who's diabetic. And as you can see, there's all the different mechanisms that you get in here as well. So, is that electrical, mechanical, there's chemistry for biomedical as well. Right, water gun. Yes, please, ask away, gotta have more questions, I'm sure somebody's got something. If anybody likes to sing, you can sing into there and get those lights working.
And the EEG, anyone who works with EEG devices?
Mm-hmm. Yep. You can get it sometimes for your design project. There are researchers. If you're interested in that kind of thing, you can do what's called an undergrad research assistantship, where you work in a research lab in your undergrad. So you can get some feel for what research is like.
How about any TMS or TFUS machines?
Not an undergrad.
Okay.
That doesn't mean it doesn't exist in the research end. Any questions at all? We're a quiet group.
You know, it's entirely biomedical here.
Everyone's here biomedical?
Well, they're interested at least in biomedical. Can you believe it?
Yes.
Every other group's been like 90% side.
Yeah.
Oh,
Not
so
this time.
Not this time?
I feel
You've all
very
been
left out. I still
gathering
want to
together. If you would like, you should take a walk down by. Have you shown them the
We're
whole
gonna-
Yes,
next.
we're going to,
Yeah.
yeah.
Because one of the things you do have available here, so some of these rooms get locked down, but we have kind of clones of these rooms that are available to students 24/7 to do whatever, to work on your own projects and personal projects. So maybe an example I can give of that, a couple years ago, some students were connected with it's a prosthetics group, and there was an individual in South America who lost their hands. So helped design a prosthetic hand, built here, designed and built here, sent over so the person could grab and write.
What are these machines and how do they work?
So these machines, this is part of the prototyping lab, and one of the things you learn to interact with is how to make things move. So this class made use of machines, and you can see more on the wall behind you. Every student's making one. As you progress through the course, you then learn to do more control with it. I think I showed you a bit of the control system here, right? Well, follow-up control, how do you go grab something, get a mechanism to move the way you want? Part of this project is also then talking to your partner. So they have a microcontroller here. You talk to the microcontroller over there and say, hey, I picked up my target, I moved it to place 1. And then they go, okay, if it's at place 1, I'm gonna move it to place 3. And tell you it's at place 3, and then you go and move it. And using, so you see at the back, there's some instructions there, right? That's way back to high school trade. So I'm sure everyone's really good at that right now, right? And then you can bring that back in here and learn how to get things done. how to make things move the way you want to solve the problems you're looking for. Right? And this is a mechanical and electrical one, but we do all the way through chemistry, electronics, analog, digital,
Oh, cool.
material science, so we'll do that one.
Material
Yeah,
science.
we'll head over to the lounge and the workshop then. Thank you.
Thank you.
Thanks.
Sometimes I just want to kill myself.
So technically, these are system spaces and not BME spaces. They used to be biomedical as well. They switched that last year. Biomedical has their own versions of these in DWE, which is the next building we're going to go to, that are not fully developed yet because we just got access to them last year. So they don't have as much character. But because we're sister programs and everybody's friends, we share the codes. So we do have access here. Sometimes they'll have the code actually written up on the blackboard so that anybody can get in. I've used these spaces too, even though we technically have the other space. But these ones do just have a little more character, so we're going to show these ones instead of those ones.
Yeah, so it's just like, it's a student lounge, it's coded, so only we get access to it. It's fun, we've spent many late nights here. You guys can take